Imagine spending weeks building a machine learning model, only to realize your results are completely wrong. And the best thing is, it's not because of the algorithm, it's because of your data. In fact, data scientists often spend up to 80% of their time preparing data. Raw data handle missing values. You wouldn't throw unwashed vegetables straight into a dish. Welcome back. I'm Data Science Dom, and in this video we will break down the fundamentals of data preparation. What it is, why it matters, and how to do it effectively. Data preparation is the process of transforming raw data into a clean and usable format for analysis or machine learning. Raw data is often incomplete, inconsistent, and noisy. If we compare those data sets at the beginning, we see on the left hand side, for example, the ID row is inconsistent. We have integer values, we have string values, which does not match a single criterion. We have missing age values, we have different missing age types like not available, we have question marks as a string, we have it encoded as usual strings, or completely missing values. Same for the email. Often in date formats, it's pretty important to have a consistent date format that the model can understand, okay, there's no differences in the format, and not only this is different. For the country, for example, we have USA in more than 3 times encoded. We have it in uppercase, we have it in lowercase, we have it written as United States, we have it separated by columns. We have so many different values for the same value in the end. So we need to encode this beforehand. For example, in here on the right hand side, if we check to the clean data, we see we have complete values, we have the consistent formats throughout the daytime, we have no errors, typos or something like this in our country, for example. We have uniform data types, meaning I have one column, the ID is all in integer values, the name is all in string values, the age again is all in integer values, so it's easier to analyze. So if you understand the data better, for example in an Excel spreadsheet, then the model will understand it better as well. So think of data like cooking. You wouldn't throw unwashed vegetables straight into a dish. You clean, cut, and organize them first. Poor data leads to poor results. This is often called garbage in, garbage out. Even the most advanced algorithms cannot fix bad data. So clean data improves model accuracy, training speed, and reliability of results. The first step of data preparation is the data cleaning. For data cleaning, we have to handle missing values. For example, in here, the age. This can be done by either taking the mean value of ages or the modus, etc. We have to remove duplicate records, like the same data which is repeated. If we have a complete row, we can simply remove it. We need to handle incorrect formats. For example, at the datetime earlier on, we need to get one datetime value for everything. Or at the age, we need to encode it as integer, for example. And the last thing is outliers. Those are abnormal values. Those values are really far away from the average. For example, in the salary, we see one person, the Tom Clark, has around 1 million of salary. This will really dramatically change the mean and increase the standard deviation. In many cases, you either handle outliers by removing them or signal the model later on, this is an outlier, this is not normal data. The second step is the data transformation step. So we convert data into a suitable format for a machine learning model. For example, in the first step, we encode categorical variables because we have text labels which don't have a meaning to the model. This can be done into groups to have integer values. The second step, which is seen on the right hand side, is either the scaling or the normalization. In this step, for example, we try to scale the features, the different feature values, into a common scale. For example, if we have a weight, this will go up to, for example, if we have a kilograms, for some people until 100 kilograms. If we have a height, this will be up to 2 meters. So we compare a 2 with a 100. So if we have like a distance space, the weight will be much higher than the height in the end. If we convert it with kilograms to centimeters, okay, this will be more comparable. But in this case, we do a min-max scaling or a set score standard deviation scaling. We can go into this into more detail into the equations. But for example, the min-max scaling is just we take the current value, subtract from it the minimal value of the feature, and divide it by the bandwidth of the whole value. And so we have features scaled to a common numerical pattern between 0 and 1. And another step is converting data types in the end. The next step and the most important step is to subscribe to the channel and like the video. The third step is the feature engineering. This is where we create new variables from existing data to improve model performance. This can be done by, for example, extracting information from existing features. If we have a date, we can extract the date, the month, or the year. We can combine existing features to create new insights. For example, the height and the weight can be combined to an BMI. But the most important part is here, we require domain knowledge and creativity. So you need to understand the domain to create new features. Right here, we see some examples therefore. We had a date, there we extract the day of the week, the day, the month, and the year. But it is important later on to check if features correlate with each other. If we have the date information and have everything else and they correlate with each other, which they do, then we need to check if both are important for our model later on. If we have the height, weight, we can create a BMI, and so we can create some better insights or maybe increase the performance with feature engineering. And in the fourth step, we need to split the data. Therefore, we make a train, validation, and test split. We have training data to train the model, validation set to evaluate the model during the training phase and set some parameters, and the blind test set where we later on test everything. If you don't know what those stages are, check out our video about machine learning tasks. Some common mistakes in data preparation include ignoring missing values, data leakage by using future values for training, or overcleaning and removing useful information. So being careful at this stage will save you a lot of time later. To summarize, data preparation is a critical step in any data science workflow. It includes cleaning, transforming, engineering features, and splitting data. Mastering these fundamentals will significantly improve your results. Thanks for watching, and remember, create models, start with great data.